Okay. All right, so welcome back. We are, I guess this is week 3. What we're going to be for CSE 101, and this week we'll start doing selections, if statements. One thing I do want to go ahead and make a note of on the video as well is, so I've had a number of you who are you either have some reason that you cannot join the live lecture. Some of you are taking this class for a second time or a third time, and you have another class at this time, and so we want you to be able to attend that one. The other thing, there's a few of you who've also expressed that you're unable to have access to consistent internet, and so what I've done is, for anyone that sent me an email requesting that or contacted me requesting that, then I replied and I sent you an email that talks about some of the options that we can look at for trying to get you the credit for attending, for viewing the lecture, and for the quizzes also. So if that is you, if you're in that situation, then you can, and you did not receive an email from me about this, then you need to go ahead and send me, contact me today or tomorrow, because I think the deadline that I posted according to the syllabus for contacting me about that issue was tomorrow, the Friday of the 3rd week of class. So for those of you who are here live, I went ahead and went through that here on this call, so that the ones watching the recording later will have that that reminder again. So, all right, so let's go ahead and get started. Let me see. Let me go ahead and share my screen. So what I'm going to do, I'm going to share desktop. Okay, why is it not? I think, let's see, there we go. Okay, so what you should be seeing now is this selections title screen. So as way of review, what we talked about last week was kind of elementary programming, how to declare variables, how to assign variable values, how to get input from a user, how to display things to the user. Okay, so that's all kind of the basics of what we're going to do. In fact, you've seen that there's an assignment that's been posted. The first program in that assignment, you should be able to do that just off of what we talked about last week. Okay. The second part of that assignment, however, you will need what we talk about this week in order to complete that assignment. But after we're done with this set of slides, after this selections slides is done, you will be able to complete all of assignment 1 with no problem. Okay? All right. But first things first, my quote of the day. So this is used to be, I don't think it is right now, but it used to be my signature for my emails. I thought this quote was, I love this quote. Computer science, first engineering discipline, in which the complexity of the objects created is limited solely by the skill of the creator and not by the strength of raw materials. A guy named Brian Reed wrote that. So what does that mean? Basically, with other engineering fields, civil engineering, mechanical engineering, electrical engineering, to a degree we are limited by what we can do. You can't, if you're a civil engineer, you cannot create a steel beam that has infinite strength, right? You have to live within the bounds. You have to live within the limits of what physical materials can do. But with computer science, we can do this. We can create a model of a building that has steel beams of infinite strength. Will it be useful? I don't know. But the main thing here is that the primary limitation in what we can create inside of a computer is limited by your brain, my brain, other engineers' brains, only what we can think of, right? And so as you go forward in life and try to use the skills that you've been given, try to, there's a phrase we use called think outside the box, right? Someone was the first person to think, I think I can create a telephone that doesn't require cables between the two phones in order for people to talk to each other. Someone created the first mobile phone because they thought to themselves, do we really need the cables? Right? Before that, all we could do was telephones with cables between two places. But now, not only can we talk to each other, but I can actually talk to you with no cables, right, through Wi-Fi, and you are not even maybe sitting in the same city as me right now, right? And all this is being done primarily through non-cables interaction. So don't be limited just by what exists. Think about what could exist as you go forward. Okay? All right. So motivations. What are the motivations for these selections? Well, based on what we've already learned, right, we could create a circle with a negative radius according to the program that we wrote last week, right? Where you computed the area of a circle given a certain radius. Remember, pi times r. Well, what happens if the user enters a negative value? Is that okay? I mean, our program wouldn't have a problem with that, right? But that would not be a good program, right? We would want to be able to have some type of way to test if a good input was given. Another example I often come back to is one example that I come back to a lot is this banking example, right? Where if you go to the ATM, you go to the to get money out or to put money in. Well, you want to be able to test if the person, right, if the customer put in the correct PIN, right? So you put your card in, you put in your PIN code, and then you can start interacting. You can start getting money out or putting money in. Well, what if they put in the wrong PIN? Right? We don't want them to be able to access the account with the wrong PIN, right? Okay, so these are some motivations for why we would want to be able to do something. If something is true, do something else if it's not. Okay. All right. Some of the objectives of what we're going to be doing through this set of slides. All right. So I want to introduce you to what's called the Boolean type and operators. Okay, so there are a number of operators that we're going to use. We've talked about operators before, mathematical operators, string operators we'll talk about later. But mathematical operators like addition, subtraction, remainder. Hopefully you remember the remainder operator. Okay. Well, there's a type of variable, a type of data type that we call a Boolean type. It's based on a guy his name was George Boole, and it's named after him. Okay, and basically a Boolean is simply something that can be true or false. Okay, so here we would say B. We would declare it the same way we would with any other variable, integer, double, whatever. But here we would say Boolean with a lowercase b, B-O-O-L-E-A-N, right? Equals 1 is greater than 2. Now, you and I would take wait, there's something wrong there. Actually, there's nothing wrong in terms of syntax with this, the grammar of the code. Simply what would happen is this would evaluate 1 is greater than 2. The program would look at that and say, well, that's not true, so it must be false. So what would happen is this variable would be assigned a value of false. That's all that would happen. Nothing wrong. The code would run. This is not a compiler error or a runtime error. It could be a logical error, but it might not be. if it should be true, if we want to have a value of true in this situation and we get a value of false, that would be a logical error. But right now we don't know what this is. All right, this might be perfectly fine, no error at all. Okay, looks like I have a comment. Let me take a look here. Oh, okay, good. All of you are just good. I'm glad you guys caught that. All right. Was there a question though up? Absolute value. I'm not sure what. Oh, I see. Okay. You're saying if they enter the negative number. Okay. Yeah, you could, but what if what we want to do is display, hey, you entered a wrong value, you entered a negative input, and that's a bad thing. All right. So yeah, you could just change the value, but what would you do if a user put in a wrong PIN code? Back to that example, you couldn't just say, well, change it to the right PIN number, because then that would be a problem. Because what if the person doesn't have, what if they have your ATM card and it's not you? All right. Okay. Let's see, is there another comment question here? Okay, everybody's commenting that. Good. All right. All right, so moving on. So greater than, you guys should recognize this, right? That's from your elementary school math. My daughter in 3rd grade is going through this right now, right? So I'm explaining these things to her, but there's other ones as well. There's other types of operators. So here we want to use, we can have a less than operator. Right? Example, if the radius is 5, radius is less than 0 is false. Less than or equal to, right? So this is the way we type it in Java. This might be how you would draw it in math, right? Less than or equal to, greater than or equal to, and not equal to. Now, I want to point out these two right here, the last two, okay? The reason being that you'll notice that it's 2 equal signs. This is probably for, I would say, for programmers, especially in languages like Java or C, that have 2 separate symbols for these 2 functions, for these 2 types of operations, is one of the things we get confused about and we get messed up with a lot. I would say it's worse in C than Java for certain reasons, but the 2 equal sign Java operator is asking, is the thing on the left equal to the thing on the right? Okay, it's asking a question. It's saying true or false, the thing on the left is equal to the thing on the right. Okay, the single equal sign is an assignment operator. It's saying take the thing on the right and put it into the container, the variable on the left. Okay, so if you type a single equals and you think that you're asking the question, then that's not right. And that's probably one of the things that happens a lot in programming, is we think we're using a comparison operator, something to compare left and right with, when in actuality they use only a single equal sign and it becomes an assignment operator, which is not what they wanted to do. In Java, that will generally be a compiler error, because Java usually catches those. There are times where it won't in certain situations, but generally it's a compiler error. In C, it's actually usually a logical error. Okay, and there are reasons for that. The last operator here, the exclamation point equals, represents not equal to. So the exclamation point in Java is going to be not. Okay, it's also going to be used for, as we'll see in a moment, as a way to make a logical not. Okay, but basically, it's what happens is if the thing on the left is not equal to the thing on the right, then it gives us true. Okay, so for example, here, if the radius is 5, Is the radius not equal to 0 true? Yes, the radius is not equal to 0, so that's why it's true. Okay, it's another thing that can be sometimes confusing when we're doing these logical things is the not equals. We think, well, it's not equal, so that should be false. But it's saying, is it not equal, true or false? Okay. Look at this example today. I want to go through the slides first so that you can kind of see, get the general information, and then I want to move on into examples as a separate thing, okay? But basically, we will go through this example of an addition quiz where the program will randomly generate two single-digit numbers, two single-digit integers, display the question, what is the sum of these, and then the student will type the answer, will type an answer in, and if we are correct, the program will say, you know, congratulations, you got that right. If we are incorrect, it will say, no, that's not right. Okay? All right. So, we'll have this if, we'll have an if statement in there. And so I want to introduce you to the if statement. Okay? So we talked about this Boolean true false condition, right? True false variable, true false expression, right? If we put one inside of an if statement, basically what happens is if this is true, we do the stuff inside of this block. Okay. So if the radius is greater than or equal to 0, in other words, the user entered a non-negative number, then we say, okay, the area is radius times pi. And then we display what the area is, and everybody's happy. Notice this is called the one-way if statement. The reason why is because if it's true, if the result of the Boolean expression is true, we do whatever the statements are. If this is false, we don't do anything. We just skip over the block. So in other words, what would happen if the radius was negative here? What would happen is it would just skip over from this curly brace to this curly brace and continue on with the program. Okay. So it's called a one-way if statement. If it's true, you do some stuff. If it's not, you just don't do anything. You just skip over that block of code and you keep moving on. Okay. All right. One thing I want to make sure you're clear on, all right, is this curly, parentheses and curly brace stuff, okay? So you need to put the parentheses around the Boolean expression. Okay. So go ahead. Other languages don't require that. So anybody who has some previous programming experience, you'll maybe get a little bit confused by this. Sometimes while your program's not running or something. But in Java, go ahead and put those parentheses around the Boolean expression. So just get into the habit of if space open parentheses. Just get into that habit. Okay. The other thing I want to note is these curly braces. So you saw in the previous slide that we had this curly brace here that closed, that started the block of code that's inside the if statement, ended the block of code that's inside the if statement. Well, if we only have one line of code inside of the if statement, okay, or one immediate line of code, I should say, inside of the if statement, Java gives us this neat ability where we don't have to use the curly braces. What happens is with this, if this is true, the very next line, that's the only line inside of that if statement. Okay. In other words, if there's another line right after this, then it'll be considered to be outside of the if statement, which means no matter what, if there's a third line, so if is the first line, system.outPrintln is the second line. If there were a third line of code here, regardless of its indentation, it could be indented at the same level as this system word here. If there was a third line of code here, it would always be executed, regardless of the result of this if statement, because it would be seen as outside of the if statement. Okay. Okay. So one. So you may be wondering, okay, well, we have this if, but what if I don't want to just continue on? What if I want to say, you know, I want to maybe give them a message if it's false and say, hey, this was a negative number, or I want to do something else, right? Well, we can have this what's called the two-way if statement. So if the expression is true, we have some statements for the true situation. Else, we have statements for the false situation. Okay. Notice it's two separate blocks of code. So it's going to either go this path or it's going to go this path. In a situation like this, you can say one of these sets of statements will be executed. Absolutely, one of them will be executed. One of them will not. Okay. One thing that can kind of trip us up a little bit is in a Boolean expression, it's always either true or false. There's no other option. There's no like maybe, or sometimes true, sometimes false. Like Boolean expressions are either true or false. It's one of those two. It can't. There is no third option. Okay. Yeah. So postmodern, millennial generation, whatever, it's you don't get a third option. It's either true or false. Okay. So an if-else example. Okay. So we want to display the area if the radius is not negative. We want to display the area. Otherwise, we want to display a message that says, hey, you put negative input in. Okay. So it could get confusing because if we don't have this else, right? If we didn't have this, if we just only displayed the area if the radius was not negative, then what would happen? If they entered a negative number and maybe they didn't realize that they entered a negative number, maybe they accidentally hit the hyphen for negative, or maybe they didn't know that negative numbers were not okay. Maybe they thought, oh, well, there can be negative radius circles somehow, right? Then what would happen is our program just wouldn't display anything and they would have no clue. They wouldn't know, hey, why is this not showing me my area? What's going on, right? We want to try to, when reasonable, give users information about why maybe their program didn't do what they thought it should. Okay, so for example, if you went to the ATM, you put your card in, you enter the wrong PIN code, and the ATM just sends your card back out and doesn't do anything. You'd be like, what's going on? What's going on? Right? If it didn't tell you, you put in the wrong PIN, you wouldn't know what was going on. Okay? That's why we need the else conditions. We can have multiple alternative if statements. So you can have if the score is greater than or equal to 90, we're going to print an A. Else if, so the only way we get into this else is what? If the score is less than 90, right? So else, okay, so what does that mean? This if statement here, the only way we get into it is if the score is greater than or equal to 80 and it's also less than 90. So it's got to be between 80 and 89.9, right? So the only way we get into here is if this was, the only way we get into this if statement is if this was false. Same thing with this. The only way we get into this if statement was if this was false and this was false, but now this is true, and so forth, okay? As you will start to discover the more code you write, writing your code in this tree, what we call the tree format, can get really problematic the more and more else ifs there are. All right, because it can get really long and kind of way out there and just kind of get confusing. So this can be better. Okay? If you get a long string of if-else's, then you want to go ahead and and put the second if on the same line as that first else. Then this if goes on the same line as that else. Java allows this. This is a syntax correct thing. Okay. Again, some of you may have some previous programming experience, like Python, where instead of having an else if, you have an elif, and some other things like that. Okay. But for here, for Java, this would be a good syntax. This would be a good way. Mostly because we can definitely see this set of if else's kind of all go together. They're all kind of trying to do a similar thing. They're trying to calculate someone's grade letter based on their grade value. Okay. All right. This would be a flowchart version of how this would look. Okay. If score is greater than or equal 90, true, do this, otherwise go here, true, do this, otherwise go here, otherwise. Okay, so the only way that grade is F could be displayed was if this was false, this was false, this was false, this was false. Okay. So you might say, well, wait a second, why don't I just test way back up here, is the score less than 60 and display F there instead of having to go through all that? You could do it the other way. You could say if score is less than 60, else if score is greater, less than 70, if score is less than 80, and so forth, and do F, B, C, B, A. That would be okay as well. The problem is that we need to have a way to say, okay, is the grade in this range from 80 up to 90, okay? And that's why we need to do something more like this. We'll talk about another thing for discrete values. This it's called the switch statement towards the end of this lecture slides in the second hour. Okay. All right. So if we want to trace, right, how this would go, so if we assume the score is 70, for example, okay. Is the score greater than 90? No. So we go here. Else, if score is greater than 80, greater than or equal to 80, no. Keep moving. Else, if score is greater than or equal to 70, this is true. So we're going to go into this line. Right? So now we're at this line. We're going to print. Grade is C. We're going to print the letter C. Right? That ends this if block. Right? And so we're done. We're done with all of this because once we get into an if statement, we don't go into its else. We just skip all the way over. Okay, we just skip all the way over all of the rest of this else because we're done with this, right? We've already gotten into an if. We're out. Okay. This is another thing that can sometimes be confusing for some programmers, is that they think, well, I got into this, but then I also want to but I may end up getting in here somehow also, especially if some of these conditions are what we call not mutually exclusive. So, for example, here, right, we know that if we get into this if statement, we can only get here if the score was less than 90 and less than 80. Right? We couldn't get here if one of these was true and this was also true, right? But there are some times that some of these conditions, we can end up in a situation where this is true, but then also a later condition is also true. So for example, well, I mean, let's look at that as an example, right? The score is 70. This was true, but this was true also. But the reason we don't come in here is because since this was true, it means we skip over this else. So we don't even test this condition. We just skip on over it. Okay. Make sure you understand that. That's very important for us to understand how this flow happens. Okay. By the way, this if statement it's called a control. It's like a flow control. I have to look up the term for it. There's a general term for it and loop conditions. It's I'll have to look it up during the break. My English is escaping me. My Turkish is getting better, but my English is still is getting worse as my Turkish gets better. I'm sure you guys can relate. Okay. All right. So one note to make, the else clause matches the most recent if clause in the same block. Okay. So it's not about indentation. Again, for anyone who has programmed in Python before, Python is about indentation. So you're going to have to get out of that mindset. Okay. So the else goes with the most recent if. It may not be the one that matches up indentation wise, which can get confusing. Sometimes we think, oh, this else should go with this if because it's the same indentation level, but that's not right. This else goes with this if because it's the most recent if in the block, okay? So what happens? If I is greater than j, if I is greater than k, system.out line. So this is the line inside of this if statement. This else goes with this if statement. So this is the correct indentation way to look at it. Okay. One thing that this talks about here that this shows an example of is what's called a nested if statement. An if inside of another if. So is I greater than j? No, so we wouldn't even skip over it anyway. But if it were true, then it's asking, is I greater than k? All right. So if both of these are true, then we're going to print A. Otherwise, let me look at the correct indentation one. Otherwise, how would we print B? The only way we could print B, actually go ahead and type out. So under what situation would A get printed? Under what situation would B get printed? You could even just type out some example values of I, J, and K. So I'll leave that out there for you guys to answer. So that's a good question. We'll come back to it with some examples in just a moment. Okay. All right. Now, if what we intended, right? If what we intended was for this else to belong to this if, we can force that to happen. So here in this situation, we can add these curly braces to say, I want this to be inside of this if statement, and I want this else to go with this if statement. So we can force it by using these curly braces. So in this example, this statement would print B. And the reason why is because we go to this if, I greater than j is false. So we don't go inside of this if statement. We jump over that if block. We see an else. So now we print B. Okay. All right. A few common errors I'll go through. A semicolon ends a statement. Okay. A semicolon ends a line of code, not an if statement, not a while loop, not a method declaration. Right? So this is wrong, and the reason why is because this compiler will say this is a line of code, and it won't care about the result of this if statement. It will still execute all of this. Okay. So the fact is, what will happen is, if the radius is negative, it will still compute the area and display the area, which is an example of a logic error. This code will compile, no problem. This code will run, no problem. this code will give us bad results. Logic error. Okay. All right, so make sure you remember no semicolon on the end of an if statement. All right. One thing that I want to point out here is we don't always have to use if statements. Okay? So for example, we could use a Boolean variable. If the number remainder operator 2, so what does that mean? Do you remember what the remainder operator does? You guys all remember the remainder? If I divide number, if I divide it by 2, if the result is 0, I have an even number. Right? If I divide 4 by 2, I get 2 with a remainder of 0. If I divide 8 by 2, I get 4 with a remainder of 0. If I divide 11 by 2, I get 5 with a remainder of 1. Okay, so it's an odd number, right? So here we could say if the number divided by 2 gives me a remainder of 0, then my number is even. If my number, when I divide by 2, I get a remainder that's not 0, then I'm not even. Okay? We could do that without an if statement by just assigning the result of this expression to a Boolean variable called even. Okay? All right, I hope that's clear how we can do this and this, how these two can be the same thing. This most comes up when we get into, in a few weeks, we'll get into what's called methods. You may be familiar with something called functions if you've done any programming before. Methods are like that. But methods oftentimes return a value. And what oftentimes as programmers, what we do is we feel this need to assign a variable inside the method with a value and then return the variable. When in actuality, we could just return the value without having to assign a variable. All right. So this is kind of like that, where we don't really need this whole if statement if what we're doing is a Boolean expression anyway. Okay. Let's see. All right. Okay. If even equals true, print it is even. Well, we don't need to use this double equals on a true for a Boolean value, right? What is this going to give us? This double equal sign, it's a Boolean operator that's going to give us a Boolean value. Well, if even equals true, what's the result of this expression? True. If even does not equal true, what is the result of this expression? False. Guess what? We only have two possible values if even is a Boolean variable, right? It can only be either true or false, right? So if even equals true, it'd be the same thing as if true. If even is false, if even does not equal true, the result of this would be false, all right? So I hope that's somewhat clear. All right. This is a good example. We won't go through this one in the class today, but I do want you to look at it outside of class. It's a good example of how to use if-else statements or to use a Boolean variable. You can also use Boolean variables. Maybe I thought about using that one and not doing this one. Yeah. Okay. All right. What we'll do is we'll look at the BMI one. I'll make a note of that. We'll look at the BMI one as an example, but then I'll leave the computing taxes one for you to look at outside of this lecture. All right. So the next set of slides we're going to get into logical operators. I want to hold off on that until the second hour. So it's a little bit early, but what we'll do is we'll take a break unless there are questions that I need to answer. Let's take a look. Yeah, like the double equal sign checks if it's equal. A single equal sign assigns a value. Yes, you need to use if statements for assignment 1. You don't need to use them for the first program, for the My Life Goals program, but for the other one, the second program, you will need to use if statements, okay? Start again if it's false. I think you're meaning a loop, and we will get into loops next time, okay? I was gonna say, okay, so that's all answers to the blank. Good, good. You guys got the message. All right. Right. If the braces are missing, then that just means there's a single line of code in the if statement. Okay. In a lot of American universities, that's true. Obviously, not in all Turkish universities, but these slides are based on an American book, so that's why it's done. It's American grading scales are 90, 80, 70, 60. They also only use A, B, C, D, and F, whereas here in a lot of Turkish universities and in Octanes especially, we have this whole much finer grading scale like the AA, BA, BB, those kinds of grades. Why don't we print A, B, and C when the input is 90? Well, you would print A if the input was 90, but then the else would mean you'd skip over all the other if else's. Not sure. I'm not sure I understand the question here, Ersin. So maybe you can ask it again if you like. Oh, I see what you're saying. Yeah, well, we don't know how that's the score got entered. It might be through Next Double, through a scanner. It might be through some other calculation of other inputs. So that value, because the variable would have to be a double type variable, then we know for certain that it won't be some other characters. No, yeah, Mustafa, unfortunately, elif cannot be used because the Java has its own syntax. Okay. Yep, that's right, Pradhan. Perfect. Right. You won't get a negative grade in my class, so I hope you feel okay with that. Let's see. Right, something like that. You could do that. Yeah. But again, normally this grade for like a final grade would be based on the calculation of other scores throughout the way. Right, if you write it 110 would still be an A. Right, because if you are able to get 110 in this course, you would still get an AA in this course, so that's right. Remainder, yep. Right, good. Mod or remainder operator, yep. No, the university has their own chart. I believe I included it in assignment 1, and that was taken directly from the university website. Right. Yeah. Again, 110, 150, anything above 90 would be an A. So if you were able to get 120 in any course, you should get an A. Now, I can tell you that from experience, the OBS system does not allow for grades above 100. So unfortunately, even with bonus points, I can't give you anything above 100. So, okay. So I think that covers all the questions. So it's 10:20. Let's go ahead and take our break now. I'll stop the recording and we will see each other again. We'll see each other again in about 10 minutes, okay, at 10:30. All right.